So on number 10, we are asked to find ST, which I'm going to call as X. And what I notice is I have parallel lines. Now what I learned before with the theorem was that if I have parallel lines, then it cuts these into proportional segments. So what we want to make is a proportion. So if you look at your proportional segments, 12 is directly across from 16. 14, which is on the same side as that 12, so keep it on the same side, is directly across from the x. Now we can just cross multiply. So we want to do 12 times x, which is 12x, and 16 times 4, which is 224. When I divide both sides by 12, x is going to be 18.6 repeating. And so that x represents ST, so ST is 18.6 repeating. Let's look at number 11. Number 11 is that one that I think is always a little tricky to find, but notice here I marked these angles. If you have two congruent angles and this bisects that angle, then remember you can set up a proportion where you go straight across and say 6 over its side 8 is equal to. Now look on the same side of the triangle as 6 and we have 4y minus 1. Look on the same side as 8 and we have 5y. Now we're ready to cross multiply, but when you cross multiply, don't forget there's a parentheses up here. So it's going to be 6 times 5y is equal to 8 times 4y minus 1. 6 times 5y is 30y. 8 times 4y is 32y minus 8. Don't forget to distribute. I'm going to go ahead and add 8, so I have 30y plus 8 equals 32y. I'm going to subtract 30 from both sides, so 8 is equal to 2y. When I divide both sides by 2, y is equal to 4. Now let's go ahead and answer the question, because the question asks me to find AB, so I need to plug it in. So AB, let me push this up a little bit, is going to equal 4y minus 1, which is 4 times 4, which is 16, minus 1 is 15. And then we also need to find AC. AC is equal to 5y, so it's 5 times that 4, so AC is equal to 20 units.